Welcome to the CompTIA 220-1101 or Core 1 exam, Objective 2.6, VLANs and VPNs. A LAN is a local area network. We commonly define this as a group of devices that are in the same broadcast domain. In this example, we have 3 different switches. Each switch has a different computer, and we can network them together on a LAN in the same broadcast domain. It would be much more efficient and cost effective if we could buy a single switch, maintaining a single power source for that switch in a single configuration, and logically associate these different interfaces, such as the VLAN 1 that's red, the VLAN 2 that's blue, and the VLAN 3 that's green. The switch itself would provide separation between these networks. These devices would not be able to communicate directly to each other. We refer to this as a virtualization of the local area network, or as a VLAN. This is the grouping of the devices that are still in the same broadcast domain, but we're doing this across the same physical device. This means that we don't need to separate switches. We can instead have the same functionality on a single switch and configure VLANs for each of these individual interfaces. Okay, so let's look at this diagram here. We have a gate room, a dialing room, and an infirmary. We have a red network, a blue network, and a green network again. And you can see that we've connected different devices to these interfaces. As a network admin, we've specifically configured the interfaces on the switch to match a certain network. So in this case, if you're connected to port 1 on the red network, then you're connected to port 9. If you're on the blue network and you're connected to port 17, you're on the green network. So you can use different number systems and how it traces to the patch panel to number and know where each panel goes. Of course, instead of using colors, we can associate a VLAN with a number. So the red network might be VLAN 1, the blue VLAN 2, and the green VLAN 3. You can see that not only does this make it easier to manage the network, but now we can keep costs lower by having a single switch instead of purchasing 3 separate switches for 3 separate VLANs. A technology that has become rather commonplace on our network today is a VPN, or a virtual private network. This is usually a combination of software and hardware that allows us to securely send information across a public network, such as internet. Everything sent over the VPN is private and encrypted, so that means if someone's in the middle of the connection, they wouldn't be able to read those packets. It would be scrambled. If you've used a VPN, then you certainly are familiar with how that looks from the desktops of your operating system. But somewhere it's connecting to a separate device, and the device we're connecting to is a concentrator. This can be a standalone device or can be integrated into a firewall or some other multi-use device. There are many different ways to deploy VPNs. The example we have here is a hardware device that may have specialized VPN or encryption hardware inside of it. But you can also configure VPN software that might be running on a server. Many VPN implementers have their own application that can be installed on an operating system, and you'll find that these days most modern operating systems come included with some sort of VPN client. This means that you can still be secure when using a laptop in a coffee shop, even if the wireless network in your coffee shop is one that is open and not encrypted. You could either use VPN software and connect to a virtual private network through a tunnel, and nobody could read your encrypted traffic. This means that you can still be secure while using a laptop anywhere. So for example, this is your laptop at the coffee shop. You have a regular internet connection, maybe it's not secure. As long as you're connecting to some sort of VPN tunnel, then you will be able to access a private network of devices, as long as it's configured that way. But a lot of people often use it to just browse the web securely and not connect to any device. Okay, this is the end of Objective 2.6. Here's a pop quiz. What is the best way to limit broadcast traffic on a large segmented network? A VPN concentrator, a single hub, multiple hubs, or a managed switch with VLAN? And we would want to use a VLAN. Connecting too many devices will create a broadcast storm. So we like to use VLANs to separate that. And there's other reasons too, but that's a common one. Thanks for watching.